Chapter 1, Section 1 is going to be about expressions, equations, and functions, and being able to talk about how to write out verbal expressions or how to write out an algebraic expression based on information that they give you from the problem. The first thing I want to do with you guys is go over some vocab that you're going to need to be familiar with, because you're going to see these words show up in this section and even as we continue on throughout the school year. So the first vocab word is a variable. Variables are used to represent numbers or values, and they're a symbol-like term, so they're going to be used to represent what we don't know. So a lot of times it's a letter. So the most common variable you're going to see would be like an X, but they could also use letters like Y or M or B or anything that they wanted to. Now a constant would be a specific number. So like 2, could be a -3, could be a +5. But notice how those are different from each other. So a variable is going to be a letter that represents what you don't know, or some type of symbol, and a constant is going to be a very specific number. Now factors would be when you have 2 or more quantities that you're multiplying together. And so for example, if I had the numbers like 2 times 3 times 4, these would all be factors. So each one of these would be considered a factor. Now if I were to actually multiply them across, so 2 times 3 times 4, and that would come out to be 24, then that 24 is known as the product. So the product would be the number that you get, or the answer that you get, after you multiplied your factors together. Now a term could be a number, or it could be a variable, or it could be the combination of those two things by multiplying them or dividing them. So terms can look a lot of different ways, but you might have something like just X, or you might have just a number like 2, or you might have a combination like 3Y. And when you start getting those terms combined together with addition signs, multiplication signs, subtraction signs, and those kinds of things, that's when you're going to start getting these algebraic expressions. So for example, if I had X plus 2 minus 3Y, that would be considered an algebraic expression. It's made up of those terms, but then you have addition and subtraction that separates them and creates a new sentence that we could use to solve a problem. Something else to be familiar with is when you have a base, and this comes in when something has an exponent with it. So a base would be a number or a letter that's being used as the factor, and the exponent would be a smaller number that kind of sits up in the right corner, and that tells you how many times you're taking that number times itself. So when I see something like this, 3 to the 4th power here, 3 would be the base, 4 would be the exponent. And I could have said either 3 to the power of 4, or I could have said 3 to the 4th power to represent that situation. And remember, when you have something raised with an exponent like that, it means that you're taking that number times itself. So you're taking 3 times 3 times 3 times 3 to get 81. Now if we turn the page over here and we look at this chart is used to help you write out expressions. There's going to be key phrases that you're going to want to be able to look for inside of the algebraic expression or the sentence that you're looking at in order for you to understand exactly what operation they're wanting you to use. So for addition, you might see words like add, sum of, plus, more than, increased by. For subtraction, you're going to see words like subtract, difference of, minus, less than, decreased by, or fewer. Take a note here how less than is written a little bit differently. The reason that is, and we'll talk about this a little bit more later on, is when you see less than, I want you to think backwards. So if they had something saying that you had 6 less than Sarah, a lot of times students will want to write 6 and then minus and then whatever letter they're using for Sarah, like S. But this would be wrong. okay, because it's 6 less than what she has. So when we say think backwards, you're going to take that 6 and that letter that you used for Sarah, and you're going to switch them. So it's going to be S minus that number. Some words for multiplication would be multiply, product of, times, twice. Twice, remember, means 2 times. Or like you're doubling something. Another word you might see for multiplication would be of. Division. Division would be to say like divide, quotient of, divided by, ratio of, or even per. When you're writing out expressions, what you're going to want to do is figure out what you do know and what you don't know about the problem. Once you're able to kind of organize it in that sense, you'll be able to figure out, okay, what I don't know needs to be represented by a variable, so you'll have to pick a letter to use for that part of the sentence, and then you'll be able to write out an expression to represent what was happening in that problem. So, for example here, I have $8 more than what Ryan earned. Now that key phrase more than that's in there, that's going to tell you that you're going to end up using addition, because more than was up above on that chart underneath the addition column. So you have $8 more than Ryan. So Ryan earned something. We don't know what that is, so let's go ahead and use R for Ryan. And then more than would be plus, and it's 8 more than, so it would be R plus 8. So you guys go ahead and write down what you think the answer for that practice problem should be. So 45 more minutes than what Sarah worked. We don't know what Sarah worked. We don't know how many hours that was, so I'm going to use S for Sarah. And I know it was 45 minutes more, so I need to add 45 minutes to that amount. Here's an example with that less than. So I had kind of talked to you guys already about less than and how you want to think about it being written backwards, and I have that note down here again just to kind of remind you guys. So we have 4 less than Kate. This is just showing you how you could set up a chart if you needed to organize your stuff into what you know and what you don't know. What we know is that it's 4 less than, so I know I'm going to have to use subtraction because of that less than phrase. I don't know what Kate has though, so I'm going to use K for Kate. Now remember I said earlier a lot of times students will want to put the 4 first, and then the minus sign, and then the K, but you have to think backwards, so make sure that you put K for Kate first, then the minus sign, and then the 4. So anytime you see that phrase less than, that should trigger in your brain that you're going to have to write it backwards. This example that comes up next, though, is a little different because it says the difference of. Now, the difference of is a key phrase from that chart, which also means subtraction. But this time, because it's following that word of, you're just going to write out the sentence exactly how you see it. So the difference of 7, so 7 comes first, and then your minus sign, and a number, which we don't know what that is, so you could use X or N or B if you wanted to for that number that we don't know. Now there are 4 practice problems here, and what I want you to do is try to do all 4. So go ahead, if you need some time to work through these, pause the video here, work through the practice problems, and then resume playing the video so you can see what the answer should have been. So for that first practice problem, it says the sum of. So that means that you're going to be using addition. And then it also has twice a number. So twice a number is going to be multiplying by that 2. We talked about how twice means 2 times. So twice a number would be 2 times a number, like 2n. Or 2x. And then sum means that you're going to be adding, and then that number 9. So 2n plus 9. This next practice problem says that you have a number squared divided by 7. So a number, we don't know what that is, so we can use like x. Now squared is a word for an exponent, and it's going to be a little 2. and then divided by 7. When you see a fraction like this, that does mean division. A lot of times I see students will want to write this, x squared, and then the division bar, and then 7. And while that's not incorrect, just know that going forward in algebra, you're probably going to see division problems written with a fraction bar. So it's better to start getting used to writing it that way and seeing it that way, because we're going to eventually move away from using the actual division bar sign. The next practice problem said the quotient of a number cubed and 6. Very similar to this one. You've got a number cubed, so instead of to the second power, it's going to be to the third power, and then again you're dividing by 6. Then for this last practice problem, it says 17 less than Amy. Remember, less than should let you know you're going to have to write this backwards. So Amy should come first. So if you used A for her, then your subtraction sign, then the 17. All right, we're going to move on now to solving story problems. When you get into story problems, it is really important that you're able to read through the problem and be able to kind of divide into what you know and what you don't know, so that you can understand what the problem is asking you to find and what information you have to use to help you find whatever might be missing. You're still going to want to be able to go back to those charts and use those key phrases so that you can write out an expression or an equation to help you solve these problems. So when you're solving story problems, there's 5 steps that I want you to be following. Step 1 is to familiarize yourself with the problem. What do you know? What don't you know? And once you have figured out what you don't know or what you're trying to find, that is when you're going to want to define your variable. And what that means is that you are going to want to pick what letter you want to use to represent the unknown in the situation. Once you've defined your variable, you're going to want to translate your information to an equation. Once you have your equation written out, then you're going to want to work to solve it. After you have your answer, you're always going to want to make sure that you check it. And what that means is that you look at the answer you got and you ask yourself questions like, does that make sense with what I was trying to find? Does it seem reasonable for the situation that they were giving me? Then the last thing that you might need to do is restate your answer or add a label to it. So restating just means that maybe you need to write it out away from the work so that it's easy for someone to find, or it could be that you just need to circle it so that it's more obvious where it is. And labeling it could mean that you need to put things like dollars on it, or inches, or pounds, or something like that. So let's do some examples of some story problems here. This first one we're going to work out together. It says that Seth bought a drink for $1.50 and some candy bars for 75 cents each. We want to write an equation for the amount of money that Seth spent. How much did he spend if he bought 3 candy bars? This is actually broken into 2 parts. The first thing they want you to do is write an equation for the amount of money that he spent. And then they want you to figure out how much he spent if he bought 3 candy bars. So I created this little know, don't know chart here. And the information I know is the cost of my items. So I know that it's $1.50 for a drink and it's 75 cents for a candy bar. Originally, if they hadn't told me how many candy bars he bought, I wouldn't know that information. And so that's why I put that in the don't know part. Now what I could do is write an equation to represent this situation. So I know that he spent $1.50 on a drink. And then in addition to that, so I have to add this on, he bought some candy bars for 75 cents. So I'm going to put 0.75 for the cost of the candy bars next to C. Because if you think about working at this cash register, for example, if he had bought 5 candy bars, you could sit there and take 0.75 plus 0.75 plus 0.75 5 times if you needed to do that. That would take a lot of time though, especially if you bought a lot of candy bars. So instead, I'm going to multiply them because that's going to be a lot faster math. So then what I can do is take that 3 from the second half of the problem and plug that in for C. So it looks like this now. And then evaluate it, and this would come out to be $3.75. And that would be how much he spent. So I want you guys to do something similar here with this problem. So again, if you're watching this, I want you to take a minute, pause this video, try to do the practice problem, and then come back and keep watching to see how it should have worked out. So for the equation, you have sold 5 tickets already, so you're going to want to make sure that you write that 5 down and then add it on to what they're telling you that you need to do in order to win. So it says that you need to sell 3 times more than Jenny. Well, we don't know how many Jenny is going to sell, and so I'm going to write 3 times a letter, like J, for Jenny. Now, if she sold 4 tickets, so for the second half of this problem, what I could do is take 5 plus 3 times 4, like that. And that would be 12 plus 5, so you're at 17 tickets. All right, for this next couple of problems here, these are going to work very similar in how you set them up. So I'm going to go through the example, and then you guys are going to do the practice problem. The example is talking about 3 consecutive even integers, and the practice problem that you're going to do is talking about 3 consecutive odd integers. And even and odd numbers do behave the same as far as how far apart they're spaced on the number line. So that's why you're going to know that you're going to set these up the same way. So let's go over what the problem says and kind of what some of the information is telling you so that you know how to try to set this up. So this first example says that the sum of 3 consecutive even integers is 378. And we want to figure out what the integers are. So first of all, integers is a word that we use to represent positive and negative numbers. So it could be any number, positive or negative, that would work for this problem. But they do have to be whole numbers, so we don't want to be looking for any decimals or fractions or anything like that. Now the sum of means that you're going to be adding these numbers together. And we're looking for 3 of them, and they have to be consecutive and even. So hopefully we know that even numbers would be like 2, 4, 6, 8, 10, 12, and so on. Now consecutive means that they go in a row, so like one right after each other. So I want you guys to think about this for a second. This is not necessarily related to this problem, okay? So for example, if I had the even numbers 12, 14, and 16. Those are all even, and they're in a row because I'm skipping over the 13 and the 15 in the middle. If I didn't know what the first one was, so if I didn't know what 12 was for my first number, I could maybe call that x. Now to go from 12 to 14, I would add 2 to 12 to get to the 14. So to get to the next even number, I would add 2. So down here, if I didn't know what the first number was, and I call that x, then I would need to add 2 to my x to get to the next even number. Now think about what you would do to go from 12 to 16. 12 to 16 would be adding 4. So, and for my x, I would need to add 4 to it to get to the third number. And this is going to work the same way for odd numbers. If I had 15, 17, and 19 instead, 15 plus 2 is 17. 15 plus that 4 is 19. So it still works for those odd numbers as well. So coming back here to my example, that's what I need to write out. X, the x plus 2, and the x plus 4. Now I'm going to be adding these all together because it says that I'm doing the sum of that. And it's telling me that this is equal to 378. So the first thing I would do is look at my x's. I have 1, 2, 3 x's, so 3x. And then I have 1, 2, and a 4 there. So 2 plus 4 would be 6 equals that 378. Now to solve this, the first thing you're going to want to do is move that 6, and you do that by subtracting 6. So we have 3x equals 378 minus 6 would be 372. And then we're going to divide by 3. And that's going to give us x equals 124. So the three numbers that I'm looking for, the first one's going to be 124. And then to find the next two, I need the next two even numbers, or think about what would be 124 plus 2 and 124 plus 4. And so the next two numbers would be 126 and 128. So for this next problem, I'm going to have you guys do this one on your own. You are going to set it up the same way, because remember we were talking that even and odd numbers behave the same. So you're still going to want to have this x plus 2 plus x plus 4. But this time you're going to want to set it equal to 51. So go ahead, pause the video here, try to do this problem, find those three numbers, and then keep watching to see if you've got the right ones. So when you combine your like terms, you're still going to get 3x plus 6 equals 51. When you solve for x, so you subtract 6, divide by 3, you end up getting x equals 15. So then the next couple of numbers would be 15, 17, and 19. The last thing we're going to practice here is writing out algebraic expressions. And so what I mean by these ones is they're going to give you the equation or the expression already, and they want you to write out with words what the expression is saying. So you're going to need to switch this and actually write out the sentence for these ones. Now remember, when we saw letters inside of our expressions earlier, or when you were reading sentences before, they always refer to things like a number. So 2 times a number, or 6 divided by a number. They never specified the letter in the number. So when you're doing these kinds of problems and you see those variables in here, you're going to want to refer to them as a number. So for example, this first one, you're taking 4 times, so I'm going to write 4 times, and it's that x, or a number, to the 3rd power, or you could say a number cubed. And then minus 3. So I'm taking that expression and I'm writing it out verbally as a sentence. So I want you guys to do the same thing with the practice problems there. So for this first one way you could have said this, and there's lots of ways that you could write this depending on what type of words you want to use. One way you could have written this first practice problem is 3 times a number squared divided by 2. Another way you could have said that is the quotient of 3 times a number squared and 2. That would be another correct way of writing that. The other practice problem, you could have said 5 times a number to the 4th power plus 7. And again, there's other ways you could have written that one too, depending on if you wanted to use another phrase for the multiplication that you see happening or the addition that you see happening.